Hello. In this video, our goal is to solve a specific algebraic equation. We will learn how to find all possible values of a that make the equation a cubed divided by the quantity a plus a equal to 8 true. By the end of this video, you will be able to solve an algebraic equation that appears simple at first, but requires careful attention to detail to find all of its solutions. A common mistake people make is not considering all the possibilities. We'll make sure to explore every potential solution. Let's begin by carefully analyzing the equation we need to solve. Our first objective is to make this equation easier to work with. Right now, the term on the left side is a bit complicated. We have the equation a cubed over a plus a equals 8. Our first step will be to eliminate the fraction by multiplying both sides of the equation by a. This will help us convert the equation into a more familiar polynomial form, which is typically easier to solve. This step is valid as long as a is not equal to 0. This is an important condition we must remember, and we'll check it at the end of the process. Now, let's distribute the a on the left side. We multiply a by a cubed over a, and we multiply a by a. By doing this, the a in the numerator of the first term cancels out the a in the denominator, simplifying our equation significantly. This leaves us with a cubed plus a squared equals 8a. By multiplying both sides by a, we've transformed the equation into a cubic polynomial, which is a standard form for algebraic equations. Our next objective is to find the values of a that satisfy this cubic equation. We have the equation a cubed plus a squared equals 8a. To solve this, we want to set one side of the equation to 0. This is a standard technique for solving polynomial equations. We can do this by subtracting 8a from both sides. This gives us a cubed plus a squared minus 8a equals 0. Now we have a cubic polynomial equal to 0. To find the solutions, we need to factor this polynomial. Notice that all three terms, a cubed, a squared, and 8a, have a common factor of a. Therefore, we can factor out a from the entire polynomial. Factoring out a gives us a times the quantity a squared plus a minus 8, all equal to 0. Now we have a factored equation. This form is much easier to solve because it follows a very simple rule in algebra. In this scene, our goal is to find the values of a that make the factored equation equal to 0. We've arrived at the equation a times the quantity a squared plus a minus 8 equals 0. The fundamental property of real numbers tells us that if the product of two or more factors is 0, then at least one of those factors must be 0. In our equation, we have two factors, the single variable a and the quadratic expression a squared plus a minus 8. This means that for the entire product to be 0, either a must be 0 or the quadratic expression must be 0. This is a very powerful principle that allows us to break down a complicated problem into two simpler ones. Let's first address the simpler of the two possibilities. Our first potential solution is when a equals 0. However, remember the condition we set at the very beginning of the video? We noted that our initial multiplication was only valid if a was not equal to 0. We can verify this by substituting a equals 0 back into our original equation. Plugging in 0 gives us 0 cubed over 0 plus 0 equals 8. Since division by 0 is undefined, a equals 0 is not a valid solution to the original problem. So while a equals 0 satisfies our factored equation, it is an extraneous solution for the original problem. We must discard it. Now let's move on to the second case, which involves solving the quadratic equation. Our final objective is to solve the remaining quadratic equation to find our final solutions for a. We are left with the quadratic equation. A squared plus a minus 8 equals 0. This quadratic doesn't factor easily with integers, so we will use the quadratic formula, which works for any quadratic equation in the form x squared plus bx plus c equals 0. The quadratic formula is x equals negative b, plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's identify our coefficients a, b, and c from our equation. In a squared plus a minus 8 equals 0, we have a equals 1, b equals 1, and c equals negative 8. Now we substitute these values into the quadratic formula. This gives us a equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 8, all divided by 2 times 1. Let's simplify the expression inside the square root, which is called the discriminant. 1 squared is 1, and negative 4 times negative 8 is positive 32. So the discriminant is 1 plus 32, which equals 33. This gives us our final two solutions for a. The solutions are a equals -1 plus the square root of 33, all divided by 2, and a equals -1 minus the square root of 33, all divided by 2. These are the two non-extraneous solutions to our original problem. Let's quickly recap what we've accomplished. Our goal was to solve the equation a cubed over a plus a equals 8. We started with a seemingly straightforward equation. Our first step was to simplify the equation by multiplying both sides by a, while noting the restriction that a cannot be 0. This transformed our equation into a cubic polynomial. A cubed plus a squared minus 8a equals 0. Next, we factored out the common term a, giving us a times the quantity a squared plus a minus 8 equals 0. This allowed us to break the problem down into two simpler cases. One case, a equals 0, we found to be an extraneous solution because it violated our initial restriction. The other case required us to solve the quadratic equation a squared plus a minus 8 equals 0. We solved this quadratic using the quadratic formula. This yielded our two valid solutions. A equals -1 plus the square root of 33 divided by 2, and a equals -1 minus the square root of 33 divided by 2. This problem is a great reminder to always be careful about restrictions, like division by 0, when manipulating equations. Thank you for watching.